Well, here we go. So logs and exponentials, you will have to do a bit of revision. We did most of this last year, so I think we'll be pretty quick with it. But here we go. When you multiply bases, you can add your indices. When you divide your bases, you can subtract your indices. A power to a power, you multiply. N to the power of 0 is 1. Negative index is a positive index in the denominator. And I might make this n. If I've got a fractional index, then that becomes the x root of a to the power of n. And then a slightly more neglected rule is this one here, which is ab to the power of x. So this would become a to the power of x dot b to the power of x. That works really well when I've got, questions like this. Or actually, a better one would be if I've got a question like this. A lot of students miss this fact. So the idea is if your powers are the same, then your bases can be different. Okay, that's as we've written, slightly more neglected rule, but a really important rule. And of course, you guys know it can be written left to right. Okay, we'll just do a bit of revision of index laws, a little bit of fun stuff. Write as a single fraction without negative indices and simplify. Okay, x to the power of negative 2 is 1 on x squared, 1 on y squared, so 1 on x squared, y squared. Then x squared on y minus y squared on x. All right, I'll just pause there. Any questions for me at this stage? No, that makes sense. Then I would cross multiply. So my next line I would get is 1 on x squared y squared, x cubed minus y cubed on xy, and then you're done. X cubed take away y cubed on x cubed y cubed. All good? All right, this one down here, it says fully simplify. A lot of students struggle with these, but the trick to it, again, is just to break these up into 2 to the power of n's. So you would write this as 2 to the power of n dot 2 minus 2 to the power of n. 2 to the power of n dot 2. Does anyone not understand how I'm getting that from this?
Yeah, you lost me there.
So if I've got a power of n plus 1, I can write that like this, and the reason why I can do that is because what are you allowed to do when the bases are the same and they're multiplied? What are you allowed to do to the indices?
Add them?
Add them. So n plus 1. So 2 to the power of n times 2 to the power of 1 is the same as 2 to the power of n plus 1.
Okay.
So what would 2 to the power of n plus 2 equal to? 2 to the power of n times 2 to the power of
2.
What would 2 to the power of 5k minus 3 equal to? 2 to the power of 5k times 2 to the power of negative 3.
That makes sense.
You're adding the powers if the bases are the same, aren't you?
Yeah.
But you've got a k term, so that's why it stays as like 5k take away 3. Whereas like if it was an easy question, there you go. For these ones, you'll just go, hey, 5 take away 3, that just becomes 2 to the power of 2.
Yeah.
But now you just got a k there, and that's all. All right, cool. So, 2 to the power of n times 2 minus 2 to the power of n over 2 to the power of 2n times 2 minus 2 to the power of 2n. Any questions? All right. What are you going to do to the top? Anyone give me an idea of what they would like to do to the top and to the bottom? Yep, factorize. So 2 to the power of n, you'd factorize it out. You're left with 2 minus 1 over, factorize this, 2 minus 1. 2 minus 1 is 1, 2 minus 1 is 1, cancel out. Can anyone tell me another way of writing this one, this denominator?
We to the power of negative.
Say that again. No, I don't want to bring it up as a negative. Think of it like
it would be 2 squared bracket bracket n, right?
Yeah. So the idea is, think of this index law. This index law is power to a power. There, x times y. So you could write it like this: x bracket y. So this one here can be technically written as 2 to the power of n squared, right? Because technically you would multiply these two to get to n. If you wanted to, but that's full marks there or there. You guys get that, what I've done there? Do you understand why I cancelled that out with that squared? Yeah. Okay. Any questions? Any questions? Anybody have any questions for me here? This is not really logs or exponentials. It's just a bit of revision that we usually do with index laws. All right, this one, 24. 24 is 2 times. So the trick with these is always to break them down into the lowest factors. So 24 is going to be broken down as 2 squared, which is 4 times 3. Nope, what am I doing? 2 squared, 2 cubed, 2 cubed times 3. That's better. 2 cubed times 3. Can we see 24 can be written as 2 cubed times 3? 24 to the power of x plus 1 times 8 is 2 cubed. The reason why you break things down into the lowest factors is because once they are the lowest bases, at least they're going to be the same, so we can use our index laws. This becomes 2 to the power of 3, and then you're going to multiply this in using your power to power. Let me know if this line doesn't make sense. There you go. Power to power. Does that make sense to everybody? All right, obviously, next line, I'm just going to expand this. This becomes 2 to the power of 3x plus 3, 3 to the power of x plus 1, 2 to the power of negative 3 over 2 to the power of 2x, 3 to the power of 2x, and then pretty much collect all your 2's and then collect all your 3's. So my 2's look like this: 2, 3x plus 3. These are multiplied, so I would add them. So then just plus minus 3, which is minus 3. This is divided, which means I would usually subtract indices that you divide, so minus 2x. 3 to the power of x plus 1 divided by 2x, which means minus 2x. And then your answer is 2. 3x take away 2x is x. 3 take away 3 is gone. X take away 2x is negative x plus 1. Don't let this stress you out for index logs. I haven't done anything to do with logs. This is just term 1 revision. And if that's stressing you out because you're like, well, I'm meant to know all this, you are, but this is only ever important until the end of really the term you've been in, term 1. And then after that, you're not going to really see much of this in play for HSC or anything like that. Okay, and you can do another one when I send you this booklet. You guys can try that if you like at your own time. Maybe try that. I'm just going to move on to start. Logs. Okay. So there is a basic rule and there is a definition to be able to convert any index or any exponential, any exponential, which means x is in the power, to a log. Now, we're not going to use this log. We're not going to use this definition, sorry. So it will be unlikely you will ever see me tell you, hey, go from here to here in one line. We're going to, I guess, do it a harder way. We're going to try to prove it every time. Now, you're probably going to hate me because of that, but in the long term, all of your actual exam questions, you will need to prove. Or you'll need to actually, show the way you're going from this line to this line. So it almost makes this particular definition obsolete. So we're not going to use that. We're not going to have a one-off way to get from here to here. We're actually going to do a proper way. Okay. We would have, just like index laws, there are log laws. So we would have done this a bit last year. Log x plus log y. If you're adding logs, it's the same as multiplying your two terms. Or log of two terms is the same as saying adding the logs together. So log of 2x can be written as log of 2 plus log of x. If you're subtracting, similar to your index laws, that's like when you're dividing. This is an important one. If you've got a power a, you're allowed to bring the power down. If you've got log of a and a little sub base a, this always becomes 1. And again, we're going to prove that. I'll show that to you. Log of 1 is always 0. So that's just going to become 0. You can plug it into your calculator. You can double check that one. Okay, and just so you know these things, so logs have 3 components. They have A, B, and then C. This here is your, I guess your, how am I going to say this? This bit here is your sub base. I call this a base, and then this is called a power. All right, so when we're going log of x to the power of a, that's a power there. This is log of b, which is its normal base. These little ones down here are sub bases. So don't mix this up as this. This is not a to the power of a. Right? That's log of a with a little sub base of a. Whereas that is an actual power. Okay. So recap, when you add logs, you can multiply the insides. When you subtract logs, you can divide the insides. A power, you can bring it down, and vice versa. When you're dividing two terms, you can subtract your logs. When it's multiplied, you can add the logs. When you've got a number in front of your log, you can bring it up as a power. All right. Let's see this in play. So we've got log, okay. Most of your questions to begin with, you can ignore your sub bases. So just for you to get the hang of writing logs and everything, ignore writing subbases. All right, they're not going to affect you. They will affect you when, let's just say this was an A and this was a different number. This wasn't A, this was like B. Then there's a problem, and we're going to look into that soon. But if they're all going to be A's, which is a lot of questions, or if they're always going to be the same, then it's not going to be a problem for you. So don't let that confuse you. So I'm just going to pretty much ignore it. Okay? All right. Given log 2 is m and log 3 is n, write the following in terms of m and n. The first one says log 4. The idea is you have to find these numbers in terms of 2's and 3's. Just like above when I did, I don't know, the number 24, I wrote, oh, that's 2 cubed times 3. You know, you got to bring it up to, you know, lowest factors. Exact same thing. So log 2 and log 3 is all you have. Now they ask you for log 4. Well, log 4 is log 2 squared. Log 4 is log 2 squared. And then what do you know about powers? You can bring the powers down. And then pretty much what does log 2 equal to? Log 2 is just m. So therefore log 4 equals 2m. Any questions there? No. Log 27, let's try that. All right, log 27. Log 27 is the same as me saying log what? You got to think about how you're going to get to 27 using 2's or 3's. Yeah. 3 cubed. And then again, what do you do with the power? You might as well bring it at the front. What does log 3 equal to? And you're done. See? Maybe we'll do one more together. And then I'll let you guys just try these next 3. Log 1.5. Anyone have any ideas of how you're going to use 2's and 3's and 1.5?
You do like to log 3 on 2.
Yeah. Yeah. Perfect. Divide 3 on 2. And what do you know about 3 on 2?
It's the quotient thing. So it's
Quotient
log
thing.
3 minus. Yeah.
So when you divide, just be careful with, we're going to do it soon, a different version. That's not 2 logs divided. It is the expression inside the log that's divided. Then you can subtract your logs, which is that rule. And then of course log 3 is n. Take away log 2 is m. If you're okay, start with D. Anyone have an answer for D? Not yet?
It'd be m squared.
M squared?
Yeah.
Okay, let's have a look. So what did you do? Log 12?
Yeah,
becomes?
so I did log 3 and then does this work? Log 2 to the power of 2.
Yeah, log 2 to the power of 2. Yeah, correct. So log 3. Wait, did you split it up already?
Yeah.
What did you do? And
I read another log.
Just like this, just like that?
Yeah, just like that. Yeah.
You're close. Like you got the right ID. You're just doing a bit of mistakes. Hold on. Look, watch this. You pretty much have it. So log 3 is correct. 12 is 3 times 2 squared.
Okay.
And then what do you do when they're multiplied? You can add your logs.
Okay.
Log 3 is n. This here, you can't say it's actually m squared. You have
The
to
two
bring
down.
the 2 down and then it's an m. Yeah, so you bring the 2 down and then it's an m. So you had the idea right. It's just the just this bit here. You got to know. You got to keep it inside and then plus. That's the way that works. Oh, good job. Try E. I've got the answer down for E. You want me to go through E? No. All right, and then F. Log 13.5. That's log 27 over 2. Log 27, take away log 2. Log 27 is, we've already worked that out in B. It was 3n. Minus log 2 is m. And we're done. Any questions? All right. This was a HSC question back in 1995. Log B is 2.75. Well, the way we read it, just so you know, log B sub base A equals 2.75. Log C sub base A equals, but you know, they're all A's. So I was saying you can just ignore it for now. It just will make your math look a lot nicer for the time being. So log B is 2.75, log C is 0.25. Find the value of log B on C. Well, that looks pretty easy. Log BC squared. That shouldn't be too hard either. You guys want to try that? Oh, does actually, let's do I. Let's do I together.
Okay.
What do you do? Log B on C.
Would you sub it in first?
Well, you can't sub it in. What are you meant to do when they're divided? You can only sub it in if,
log F minus log.
yeah, you can only sub it in if you specifically have log B. You have log B on C.
Okay. So would I do log B minus log C?
And then what's log B now?
2.75 minus 0.25.
Look at that, 2.5. We got 1 mark. Easy. Easy marks. And then what would you do with this one when it says squared? Don't do that. Don't overthink it. Hours.
Oh, you can't plus.
You bring the 2 down.
Okay.
And then what do you do if they're multiplied?
You add them.
Add them. And that's it. That's all you got to keep in mind. Just going to be your log laws each time. Of course, it's your, let's just say it's your first time right now, so it's new. But as you get the hang of it, it becomes pretty much second nature.
So basically, if we memorize all the log laws, it should be easy.
Give or take. Because you got to still know how to use it. Like you got to know to actually bring the power down before you go on to multiply or add it in this case. So you got to know how to use it and what goes first and second. But yes, you need to know your log laws. Otherwise, you won't be able to get very far without knowing to put that 2 down.
Okay.
All right, you guys, start with this one. Write each of the following as log 3 with the subbase 2. What you will need is obviously this eventually. Log 2 is going to equal to 1. So you'll need that for, I think, B and possibly C. But for A, you don't need it. So you're just trying to change 81 so that you can use 3s. So that you have 3s. Okay. Stefan, do you know what to do with the first one?
Log 2, 3.
Don't look at the 2. Don't look into the 2 too much. That's a sub base. Not going to hurt us too much for now. So don't look into that. Just 3.
Okay.
81. What do you
So
think?
find what 3 and 81 over 3.
Oh, not 81 over 3. No. 3 to the. You need to get 3 into 81. So you probably want to do powers. 3 to the power of what gets you 81?
Oh, yeah.
4. 3 to the power 4 is actually 81. 9 squared, 81. So 3 to the power 4 is 81.
Yeah.
And then what are you going to do with the power?
Bring it down.
Drop it down. That just becomes 4 log. There it is. Write each of the following as this. It's just 4 of this. So log 81 is 4 log 3s.
Yeah.
Let's do that again. This one here. 2 times root 3 becomes 2 plus,
Log 3.
see, plus log root 3, right? Because you multiply them, so we add them. Now, what does log 2 become? We said it
1.
1. That's the rule, but I'll prove it shortly. 1 plus. Now, this is root 3. It's not in terms of 3. So what are you going to do with the square root?
Square.
No. Oh, good. Sorry. Yes, that's true. But when you want to square it, you got to do it to different sides. So whenever you're going to say square it, you've got to have it like solving or something. Change this to a power. So square root of 3 becomes 3 to the power of what?
Half.
Half. And then what are you going to do with the half?
Down.
And you're done. Again, it's in terms of log 3s. Last one, C, log 8 over 9. What are you going to write?
Log 8.
Minus,
Log 9.
and then 8 is going to become what? What number?
Log 8. That can become anything, can't it? 2 and 3. And log 9 can be 3 squared.
You understand everything I've just done? Brought the 3 down, log 2. Log 2 becomes 1. Brought the 2 down, log 3. This all looks very confusing at the moment because you're using all these numbers and everything. But once you stop writing your subbases and start using your lns, you'll look a lot neater. Stefan, any questions about that one?
Wait, where did the
No,
log?
all good.
Where did this one here, for this one, where did it go?
Yeah.
Log
2 is 1.
Yeah, log 2 and 2 is 1. That was this law. Log
Power
8 is equal to 1. So base and the subbase, that's the same, equals to 1. all the time. And we'll prove it shortly. Okay. Don't need that. Okay. Change of base. That is what we need. So there's got to be a way for us to plug this into our calculator. Log, 3 with a subbase of 2. And the way we're going to actually do it is by writing this as a fraction. So all of your subbases can actually be written as log of the top over log of the bottom number. Now, I think we spoke about this last year, but I'll say it again. Log, I use more ln3 on ln2, not log. And I'm not going to be too strict about it just yet, maybe for today, but maybe next week we'll talk about the difference between the two and what we're trying to do. But when I say log, I usually mean ln. And ln is log as well, just written as ln instead of log. All right, this is an important one. So log 3x can be written as log x on log 3. So if I had a question and I said, hey, go ahead and solve this, you can't do much with that right now. But if you've just learned to be able to convert this to ln x on ln 3 equals to 1, then you'd multiply, because you're going to solve for x, you'd multiply by the log 3. So 1 times log 3 is log 3. And then you've just got to now learn what the opposite of a log is, which is exponential. And technically, you just get x equals 3. And in your case, you asked just before, how did that disappear? But now you know the formula for this is actually just log of 2 over log of 2. And what's log 2 over log 2? All the time. Any number divided by itself is always going to be 1. So that's technically why that becomes 1. But this is a really important rule. This is probably the biggest thing you would want to learn out of logs. If there's nothing else you'd learn, it's a change of base. Because for all of your exam questions, you really will need a change of base occurring. Okay. So we have this question. 2 to the power of x equals 7. Without doing it, using the definition that I crossed out above at the beginning, we're going to do this like I just said, the proving way. You've got to try to find it every time. But it'll make more sense in the long run, believe me. So 2 to the power of x equals 7. Okay, this is an exponential, right? Remember, anything to the power of x is an exponential. So the opposite of an exponential, opposite of exponentials is logs. And opposite of logs obviously is exponentials. So they work the opposite, just like squares and square roots. So I would like to have x as the subject. And to be able to do that, I would really like it to write, x equals 5, let's say, or something like that. So I would like x to come down. For me to be able to do that, I have to log both sides. But look what happens. What happens to the exponential of x? What am I allowed to do with that power of x? Well, now that they've logged, I can bring that x down. And look what you get. You get x equals log 2 equals log 7, which is the same as saying log 7 on log 2. Plug that into your calculator, you'll get 2.807. The definition just says pretty much x is equal to log sub base 2 of 7. So you can just go from this to this. Now that's great for an easy question, but for the harder ones, if you don't know that the opposite of an exponential is to log it, you're not going to be able to actually solve. Okay, x equals log 7. All right. Any questions? No? No, everyone's all right. Okay, let's try a look at this. Norman Hurst, Extension 1 Prelim Yearly. So this was in their yearly exam back in 2010. Let's have a look at what to do here. 2 to the power of x equals 5 to the power of y. With x on y as a subject by taking logs to a suitable base. Well, we don't even care about the suitable base because we just do it always with like ln. So you log both sides, right? Powers, exponentials, you log both sides. You've got to learn that. And then when I ask you what's the opposite of log, you're going to say exponential. But for now, opposite of exponentials is logging. So you're left with this. Okay, what are you going to do? You're going to bring your powers down. And then, pretty much, you're trying to get x on y. So bring your y, bring your ln too, and you're done. Anyone have any questions for me? All right. I'm dying. All right, from logs double I. Hence or otherwise, find the exact value of 8 to the power of x over y. Oh, that's so easy. 8 to the power of x over y. Log 5 on log 2. Just plug it into your calculator. I don't even know why that was worth 2 marks. I think it should have been the other way around. Maybe they were trying to award students who were bothered to do double I after doing I don't even know. I think the answer becomes 125. Log 3. Just double check it for me.
Yeah, it's 125. Yeah, that's right.
Mm.
Yeah.
All right, exponential equations. You might have seen these. You might have seen these in term 1 as just harder equations, maybe with I don't know, x to the power of 4, stuff like this. Did you guys remember seeing stuff like that before? And then you let m equal to x squared.
Yeah.
Yeah, it's exactly that. It's just instead of it being a higher quadratic, it is an exponential. The trick to it is it is a quadratic. So you always choose m as the middle term. Always choose your m as your middle term. Once you've chosen m as your middle term and you know it's a quadratic, then you should already know 3 to the power of 2x. 3 to the power of 2x is 3 to the power of x squared, isn't it? Right? 2x. Let me know if anyone wants that a bit explained, a bit more.
Yeah, sorry, can you explain
So 3 to the power of 2x can be written as x and 2, or it can even be written as 3 squared and 2. And the reason why that is because what do you do with powers and powers?
Multiply.
You multiply, so that just becomes 2x. So you can write it like that, you can write it like this, you can write it like this. So by me writing it like this, 3 to the power of x squared, I know that 3 to the x is m, so then this can be replaced for m squared. But like I said, it's good for you to know that it is a quadratic, so you technically know already, oh yeah, that's just m squared.
Yeah.
Minus 12m plus 27. Factorize. Solve. What letter were you trying to solve for? X, definitely not N, definitely not M. So replace. And of course, 9 is 3 squared. So therefore X is 2 and X is 1. Does that make sense? X is 2 and X is 1. Any questions? All right. Let's do this one. Again, this one's just a little bit harder for some students to see, but I'll show it to you in this way. 3 to the power of 2x can be is 3 to the x all squared. It's also 3 squared to the x, but 3 squared can also be hidden as 9 to the x. So you've got to be careful. All 4 of these are actually the same thing. So you've got to not look at that and go, whoa, I don't know what that is, and you can break it up and replace it for something like that. That means 4 to the x can be written as 2 squared x, which is the same as, of course, 2x squared. So then you're going to let m be the middle term, and your answer becomes just m squared minus 12m plus 32 equals 0. Do you want to go and finish that off, please, and try to see if you can get x equals 2 and 3? Okay, any questions? Okay, so those were exponential equations. Then we'll get to log equations now. To solve for log equations, of course, eventually we want to find x, which means we've got to get rid of the log. Opposite of the log is to exponential it. So let's have a look at how these work. To log x sub base 3 equals log 6 take away x sub base 3. Now, I will tell you your 3's can just eliminate, but I will show it to you, which is what I said I'll keep doing. I'll prove it, but so you guys know if they're the same, just ignore them. They're not going to do anything to you. But here we go. Watch. This becomes 2 log, well, I like writing ln's, one extra letter. Think of it like that for now. 2 ln x on ln 3 equals ln 6 take away x on ln 3. And then of course, what are you allowed to do with your ln 3's? If they're both in the denominator and they're both on different sides, you can just cross them out. All right? If you didn't know you could cross it out, imagine this was multiplied up here. And then if it's multiplied ln3 over ln3, you can just cross them out anyways. So you would be left with 2 ln x equals ln 6 take away x. Bring the 2 up. You can only exponential once you have a log by itself equal to another log by itself, or a constant on this side. Even if it was a constant, it would be fine, but it has to be a log by itself. So you can't have a 2 in front of it. That's why I've got to put that 2 on the top again as a power. Now, how do I get rid of a log? The opposite of a log is to exponential it, or in this case, you could just, again, cross them out, but you're more exponentially. So they're just cancelling out. They're the opposites of each other. So you're left with, and look, doesn't this look familiar? Some more quadratics. Then you'll solve now, you got to always check with logs because there's a problem. The reason why you've got to check is because you can't log any number less than 0 or equal to 0. Won't work. We'll see that when we do the graphs, but log of any number that's less than 0 won't work. So if I'm going to sub in -3 into here, log -3, try that in your calculator, and you'll see it'll give you a math error. So, therefore, x can only equal to 2. That will be the only answer. Any questions? Let's look at that again. I first changed my base, or I realized I can just cross out the 3's, then you would have just written that as your first line. Bring the 2 up, exponential both sides, and then just solve, and then just do an extra check. You can't log a negative. Now that doesn't mean all your negative x's are wrong, so be careful, because look here, 6 take away -3, that gives you +9. Log 9 is not a problem, but it's this side, the fact that it actually becomes log of -3, it's a problem. So don't just go, oh yeah, -3, it's wrong. It's just when you sub it back in, if it gives you log of a negative, it won't work. So therefore your only answer is going to be x equals 2. All right, there's no questions there. We'll try example 16. I can't exponential it because, like I said, to exponential it can be a log. It can only be a log equal to another log. So I can't have it like this. What's the first step I've got to do with this left-hand side?
divided by x.
Beautiful. And then pretty much it just depends on how you guys see this. Like some students just see it as crossing out. You could do that, but obviously, I like you guys to know that you're actually exponentialing it, and that's how you're crossing it out, because you're doing the opposite. And then you're here, multiply, and then I think we should be able to continue from there. Gave me an answer. I think I know the answer, but anyways, give me the answer.
So are you waiting for the answer?
Yes.
It's 4.
Yeah, I thought so. I was waiting for one of you guys to work it out. All right, done. And then, of course, wait, you got to just double check. So sometimes you might get an answer of 4, and that's great. But by the time you sub it in, it doesn't work out anyways. Log 4 and 8 take away 4, both are fine. So the answer would just be x equals 4. But even positive numbers, don't feel like you're safe from them. Remember, because you can't log a negative. I'll explain that again. Look, yeah. If x equals 4, if you have to sub it into here, 2 take away 4, that's negative 2. So when you're going to log a negative 2, that won't work. So x equals 4, you would have to say it doesn't work. And in that case, if there was no solution, your actual answer is going to be no solution. So keep that in mind, you guys. All right, 2019. I think that's North Sydney Boys High School. But here we go. So they're all A's. What can I do? Just cross them out, yeah? Or if you think of them as all over A, log A, log A, log A, log A, they eventually will get rid of each other. So you can just ignore it. Might as well make your life easier. So just that becomes ln2 plus, bring the 2 up if you start to become a little more efficient with your work, minus log 6 equals log 3. Anyone have any ideas of how they would go about the next few lines?
Split the ln6 into the smallest.
Say that again.
Split the ln6, so like make ln6 like ln.
Oh, no, no need.
Alright.
No need to do that because you're thinking of the other stuff. I get what you're thinking of. Okay, just so you don't mix it up. So this is solving, yeah? The other ones were this. Just look at the difference in questions. These ones, I said it is log 3, and I want these to be written as log 3s. Or I've only got log 2 and log 3, and I want the rest written in m and n's, which means I want the rest of these written as log 2s and log 3s.
Yeah.
And that's why we had to do that. But if you don't have any restriction like that, I mean, no, you're pretty free. So, nope, your idea is, yeah?
Could you turn ln6 into 2? Wait, never mind.
You remember you want one log only on this side. You don't want all these 3 logs because you can't exponential. You can't get rid of them just like this.
Do like terms work? Like
What do you,
like ln2 minus ln6 and move it to the other side?
you could, but not required. You could. See, that's not what you just said is not wrong, but it's not what I
You do the
want.
product and quotient thing. So
Yeah,
like
right. When they're
2
plus,
plus x squared on top of that.
it's just 2x squared. You guys missing the point of simplifying 2 logs into the 1 log. And then when it's subtracted, you can just divide by 6. That's all. And then look, again, 2 logs, you can just cancel them out. You're left with x squared on 3 is equal to 3, x squared equals 9, x equals plus minus 3. Again, when you sub in negative 3 into log x, it won't work. X is going to be greater than 0 in this case. So yeah, I'm not worried about the other steps. I know those are easy. Just that first step, which we will get. I'll let you guys do this at your own time, but I will give you the pretty much the answer. 1 over 5 is 5 to the power of negative 1. Then your first equation is x plus y equals negative 1. 1 is 5 to the power of 0. Your second equation is 3x plus 2y equals 0. And then you can just solve simultaneously from there to get that. So the trick to that was the bases must be the same. So therefore the powers are going to be the same or equal. I'll let you guys look at that for homework. I would like to do that. I just want to see what's left. Okay, so this one here, solve. Log root a x plus 2 minus log root a2 equals log ax plus log a2. This is probably a little bit more advanced, maybe an extension style question. It doesn't matter. Thing is, I can't cross out the a's because of the root here. So what I am going to do is I'm going to change this to this, okay? Because we know we can at least write these as fractions, and we are okay with fractions because fractions is just like basic algebra stuff. So there we go. Okay, and then you know that root a, well, that's the same as me writing a to the power of a half, right? And then you know, oh yeah, half, I can just bring that down. So realistically, what you're going to have is this, log x plus 2 on half log a minus log 2 on half log a equals, you know, I'll just leave this as it is for now. And now what can you do with all your log a's? All gone. And then 1 over half is just the same as saying times it by 2. There. There you are. I'll just pause there. Any questions for me? Okay, at this stage, I would usually like to have x's on one side and numbers on the other side, something like Andy was saying before. I'm not going to do it. I don't think it makes a big difference right now, so we shouldn't need to do it, but you could. I would usually probably do that, but I'm not going to, just to show you, like, it doesn't really matter. And I don't even know why I'm writing 2 equal signs, I just realized. Okay, bring the 2 up. Log x plus 2 squared minus log 2 squared, which is 4. They're added, so we can multiply it. They're subtracted, so we are going to divide them. You get it. Now you can get rid of your logs because you've got a log equaling to another log. So finally we can get rid of it. And yeah, expand x squared plus 4x plus 4 equals 2x times 4, 8x, bring it all to one side. And it looks like x just becomes 2. That's a perfect square. And then always go back, sub it in. Yep, log 2 would work. Log 2 plus 2 is log 4. You're done. That's the answer. So it'll take you a bit of time to get used to all your log laws. And you said, like, is it enough just knowing your formulas really well? It's probably not, because you got to know how to use it. That's really important. Knowing to bring this up to before you're allowed to actually divide. Otherwise, if you have a 2 here and there wasn't a 2 here, you're not allowed to bring them together because they're 2 different logs. Okay. Let's look at this one, which looks like it came from Enda, which is, I think, probably university style book. Anyways, solve for x. Log 2x 216 equals x. All right, here we go. Let's see how we're going to do this. Exclamation mark usually means really, really hard. But I feel like we should be okay with it using our technique. So ln 216 over ln 2x equals x. Yep. I would usually multiply this over. So I get log 216 equals x ln 2x. Again, I'll bring the x up. And then, unfortunately, it looks like you won't be able to solve this. You won't be able to solve this because you've got x to the power of x, which is, you can't say, oh yeah, log it to get rid of the x. Well, this was logged, so it's not going to do much because you're still going to have an x in here. This is just going to be done by trial and error now. So, I feel like I know the answer. 216, I know, is 6 cubed. 216 is 6 cubed. That means x equals 3. 2 times 3 is 6, 6 cubed, yeah. So pretty much 216 is 2 times 3 to the power of 3. So that's just a silly question. That can't be done other than trial and error, then what's the point of it? Rewrite in index form, yeah. 2 times 3 to the power of 3. Or 2 cubed times 3 cubed. Prime factorizations of 216. Silly. Anyways, any questions about that? As long as you know how to get to that line right there, that's what's very important for me. All right. Graphs, which will be next week. Applications, I feel like we can do the applications, why not? 1992 unit HSC. All right, don't let the words get you, okay? Don't let the words confuse you. Let's have a look at this. A quantity Q of radium at time t in years given by Q equals Q naught E negative KT. Oh, okay, where K is a constant, so K is constant all the time. Q naught is the initial amount of radium at time t equals 0. So when time is 0, Q naught is the initial amount of radium. Given that Q equals half of Q naught, this Q is half of Q naught when time is 1,690 years, calculate the value of K. Okay, that sounds like a whole bunch of weird stuff, right? But all it's saying is this is your formula, and we know that Q is half of Q naught when time is 1690. And of course, what letter would you eventually solve for? It's saying find K. Well, can you guys see that if I've got Q naught and Q naught on here, I can just cross them out, they're the same. Right, when you're going to divide it. So you're up to this stage. half equals e negative 1690k. Okay, I would like to bring this k down so I can solve. What am I going to do to both sides?
Log.
Yeah,
Just log both
log
sides, yeah.
both sides. So what you're left with is log of half, and then bring this guy down, because you're allowed to bring your powers down now. That's the whole point of logging in the first place. And you're left with log e. Now, log and e, they're opposites of each other, aren't they? But if you plug it into your calculator, it'll give you 1. So they just cancel out. And that will be always, that will always be the case for your applications questions, because they're always going to be e's. And then you're done. K equals log 0.5 on negative 1690. Plug it into your calculator. Has to be ln. Don't put log. You'll get a different answer. Double I. After how many years does only 20% of the initial amount of radium remain? 20% of the initial amount, so that means Q is, 20% of Q naught. So it'll look like this time. And you just do it again. But this time it says after how many years? You're meant to find time. But you already know what K is. K is 0.00041. So what are you going to do to both sides? You're going to log it. So you get log of 0.2 equals negative KT. Log E cancels out. But again, I'll put it in. There it is, gone. How do I find time? Divide by negative K this time. And get the final answer out. Log 0.2. Please, let's make a quick point about this. Do not, 3924, do not use this answer. Do not ever use a rounded answer for another part of the question. Don't use rounded answers. What I just did is I did this in my calculator. Log 0.2 over negative answer button. I used the full answer of K, whatever it was going to be. You cannot use this. You write it down, you do not use it. You would have lost a mark, I'm assuming, for the second year. Let me just check. Negative 0.00041. Yeah, look, if you had used that, it would have been 3925. It would have been over by 1 year. So, please. All right, I think I'll leave it there. What time is it? Yeah, I think we're on the money. I'm happy with that. Let's stop this recording.